But of course, it's not just the air that they could react with. There are other things as well. It could also react with the water. And this is what we're going to show now. The way you may have seen this in previous demonstrations, they normally throw the metal into some water. But there's all sorts of problems with this, because the metal may have grease on it. It may be contained in a glass ampule if it's a really reactive metal like cesium or rubidium. So we're going to do this rather differently. We're going to add the water to the metal. Okay? We're going to use the same quantity of metal every time. And not the same mass, but the same number of atoms. So Mark has very carefully counted out the number of atoms, and he's got the same amount each time. So we're going to start off with lithium, and I'm going to add the same quantity of water every time as well. We're going to add 10 mils of water to our metal. So I'm going to take the top off. At the moment they're under argon, so there's no reaction of the metal with the air. Argon is heavier than air, and it's just sitting in the tube protecting the metal from the air, and we're just going to add some water. So this is lithium. You can see that it's bubbling rather nicely. It's forming hydrogen gas. And in fact, we can see the chemical equation for the reaction. It's the same chemical equation for all of the elements. We have the metal reacting with water to form the metal hydroxide and releasing hydrogen gas. So every time it's the same equation. But what we're trying to do now is see if we can tell the difference between the reactivities of the different metals. So out with the lithium, in with the sodium. Now again, it's the same quantity of metal, but does it react any more vigorously? I'm going to add the same quantity of water. All right. So the sodium, certainly a lot more violent than the lithium. In fact, it caught fire. Notice the yellow colour. This is the colour characteristic of excited sodium atoms. So the sodium was clearly having a good time there. Right, potassium. Again, the same quantity, the same number of atoms. We're trying to keep everything as controlled as possible. The same quantity of water. Just as an added safety precaution, I think I'll put this on. Right, so potassium now, and water. Getting more vigorous. Okay, maybe we can, yes, that's a good idea. We'll just remove some of the smoke so you can see the next one more clearly. Now some rubidium. Oh, we had an extra blanket, I think. Here's the rubidium in the tube here. We can see the rubidium metal under a blanket of argon. And again, it's exactly the same quantity. Every time we're using the same quantity. This is now rubidium, same quantity of water. Beautiful blue colour. That's the colour of the rubidium flame, remember. We need to wait for that to go. Okay, we'll just wait for this to clear because this is a one-off experiment here. The amount of cesium that we're using is 5 grams, and it costs several £100s. So here is our cesium. And again, if we just show this on the camera there. So there's quite a bit of the metal down in the bottom of the tube, and again, it's under a blanket of argon. Okay, so it will not react with argon gas. When I take the stopper off, it will not be reacting with the air because the argon is heavier than air. And so that will protect it until it comes into contact with the water. And we've used the same quantity of every metal here, the same number of atoms. Okay. Here is our water. And there we go. Not bad. Oh, I'm pleased that one's over. Good. Right. So actually cesium, though, I mean, it is the most reactive. There's no doubt it's the most reactive of all of the metals and reacts very, very quickly. It's also heavier than water. Both rubidium and cesium sink to the bottom of water. So that's one of the reasons it reacts very quickly. But I always think that the best reaction, actually, is with sodium and water. This is my favourite, because I think the sodium has more of a chance to sort of build up the tension and heat up. It's much more interesting. So we're going to try some more sodium now on a slightly larger scale in the tank here. Okay. Notice the amount of francium left. It's still decreasing. There's not a lot left now. So that's why we're not going to be looking at any francium. Okay, here is our sodium. Going to drop this into the tank and run away. Okay. Can't see where it is. Oh! There we go. Nearly coming to an end. So